So first of all, what is mechanical engineering? So if you come from the Polytechnic, of course, you know what mechanical engineering is, but I think to many parents, many students from the A levels, you may not even know what engineering is. So let me give you examples, and perhaps you'll get to understand a little better by understanding what mechanical engineers actually do. So mechanical engineers are involved in the design and manufacture of products. So it's both parts, both designing it and manufacturing it. And the products that we design and manufacture are those products which will carry a load. And so that means they experience some kind of forces. So examples, these products can be static objects, so they don't necessarily have moving parts. So a very good example is your mobile phone. The outside of your mobile phone needs to bear a lot of loads. We drop them, so you know they experience impact loading and all that. Buttons need to work, and they need to work well over a repeated period. So all these things are actually designed based on principles of mechanical engineering. So the mechanical engineer would actually have a lot of input on these aspects of the mobile phone, for example. Then another example you see here is it came from a recent news by the Singapore Armed Forces. It's an exoskeleton that you strap onto the back of soldiers. And this exoskeleton both helps the soldier to carry load as well as redistribute that load around your body. So this means that the heavy backpacks that soldiers must carry can then be, the body would feel that the load is lightened, and also leading to less injury and fatigue. And along the same lines, we have this hornbill. You will notice that this hornbill looks a little bit strange around his beak. So what happened to this hornbill? His name is Yari. I think he's already in his 20s, so, you know, older than the students we have here. So Yari developed cancer on his beak, and the top part of his beak needed to be removed. But when you remove that part of the beak of the hornbill, it can't eat, and it would have died had we not intervened. And so together with the vets in the Jurong Bird Park, we were able to design as well as 3D print a prosthetic for the hornbill. And you know, 3 years after surgery, he's still doing very well. So these are examples of objects that carry loads or experience forces, but are not necessarily powered like a machine or an engine. I brought up these two examples, the exoskeleton and the prosthetic beak, because you might think that this sort of examples belong to biomedical engineering. But biomedical engineering actually is just a multidisciplinary sort of, it's a multidisciplinary basket of skills from the various traditional engineering applied to biomedical applications. So here you can see that actually at the basis of such prosthetics, it's mechanical engineer. And in fact, the top researcher in the Department of Biomedical Engineering studied mechanical engineering in NUS and used to be a professor with us until he was seconded over to that side because of his interest in biomedical applications. So what I'm hinting is, if you like to do biomedical engineering, please also consider mechanical engineering. So now, of course, it's not just simple objects that mechanical engineers deal with. Very often, we also, this would be what you might expect more of mechanical engineering, where you have very complex systems that are powered and that move. So here we have a zero emission concept plane by Airbus, and the parts that mechanical engineers would be most involved in would be the following, like the airframe, how it moves, the way it moves, how we control the flying, and then of course the inside, the pressurization and any kind of restraint system and so on. So of course, such a complex system requires mechanical engineers to work with electrical engineers, electronics engineers, software engineers, and so on in order to make the planes fly. But certainly in aerospace, mechanical engineers are vital to the successful flying of any craft. Now, so other examples to that, sorry, I got a bit ahead of myself. So other complex systems or machines that move, which you might be familiar with, would be autonomous vehicles, which is gaining a lot of traction. So Tesla obviously has a self-driving, it's really not very safe. So there's still a lot more testing to go on, to be done. So in Singapore, the PSA port in Tuas, as well as Pasir Panjang, they are really trialing autonomous vehicles so that, heavy containers and everything can move 24/7 and on their own without much human intervention, thus freeing humans really to do more important and creative work. Now, another example, which you just saw, is robotics. I think everybody is familiar with robots. So here we have robots from Boston Dynamics. And, increasingly robots are actually being used in Singapore as well. And there are even locally designed robotic dogs and so on, which the Singapore Police Force uses for patrols. So robots of all kinds and all sorts of applications are going to be very, very important in the coming decades, and in fact, far into the future, because they can do things for much longer and without fatigue, and we don't really have to pay them, and they don't get COVID, right? So that's a good thing. So robotics is one area in which mechanical engineers will find themselves in demand in the future. So that's going to carry on really very far into the long term. So, what we've talked about is, you might think of mainly as designing and, functional products, but to be able to bring these designs and ideas to life, we definitely need manufacturing. And so mechanical engineers are involved in all aspects of manufacturing. So here you see a 3D printer, but there are many other fairly advanced manufacturing processes as well. In fact, in any of the other disciplines, so for example, pharmaceuticals, there are a number of pharmaceutical companies setting up in Singapore, wanting to produce vaccines and all that. Yes, chemical engineers are involved in some of the processes, but when it comes to making sure that the system runs properly, that the machines don't break down, that we employ all sorts of automation, they can't do without mechanical engineers. So manufacturing in every aspect would involve mechanical engineering. So those are the typical things that mechanical engineers do. But what you may not know is that mechanical engineers are also involved in the design and manufacture of energy systems. So what do I mean by that? So these are the broad categories of energy systems. You have things like power generation. So we are talking about renewable energy. In Singapore, you can't get wind energy, but certainly in many places around the world, wind is a big wind farms are actually a viable source of renewable energy. So how do you take the energy from spinning turbines and convert them into other forms of energy? And so that comes into conversion. First, how the power is generated through wind or through solar, and then how to convert that energy, and finally to energy storage. So later on, we will have Royston here with us, who started up a company looking at battery technology. So I'm actually I haven't heard him speak about his startup, but I'm really excited to see what he's going to tell us and how the place of engineers, mechanical engineers, lie in this future systems. So one example that I can give you is of mechanical engineering in energy and sustainable systems is this. The bulky kind of cabinet you see at the back in there, which is circled, is something called an habitat. It's essentially a cooling system that can cool the ambient temperature for several degrees without using refrigerants like our air conditioning system. So it uses water and very little electricity. So you can see it's placed here in Kopitiam in Clementi, and it's able to bring down the ambient temperature by several degrees with quite a substantial savings. And we all know that since last year, and especially now with the conflict in Ukraine, energy prices are going to go through the roof. So being able to identify these kinds of technology and improve them will definitely reduce our reliance on fossil fuels, but also when you have geopolitical events such as conflicts, that's going to cause much less disruption if we have alternative technology. So things like that, where mechanical engineers are a vital part of, is very important for the future of our planet. So those various examples sort of give you an idea where mechanical engineers are found. Essentially, you can find mechanical engineers everywhere where there is something physical to touch. So if it's a physical system, a physical product, mechanical engineers are involved. And so mechanical engineers, as I said, do both parts, both the design and manufacture. And here I'm showing you some of the industries that will be important in Singapore's economy going forward. So by the time you finish your NS and you go through your bachelor's degree, you will find that increasingly there'll be many more jobs in these areas. So part of a curriculum is to give you the tools to ensure that either you are prepared for these jobs, or you can have the basics and then learn more on the job yourself. So now I would like to talk a little bit about our curriculum. So if you attended the session earlier at 1:30, you would have heard my colleague Vice Dean, who was explaining how the new curriculum system in CDE works. So I'm going to focus more on, the part of the curriculum that's available to mechanical engineering students. Okay, so I think the rest of it is kind of repetitive, so I won't go there, but I'll delve a little bit more into this two sections, the 15 mechanical engineering major modules, and also what you can do with your unrestricted modules if you're interested in mechanical engineering. So the core modules, the compulsory ones that encompass these 15 modules under the ME space, is precisely to give you the tools for designing and manufacturing. So, I've used the word design a lot, and now that we are the College of Design and Engineering, people wonder, do I need to know how to draw things well or be creative artistically in order to design? And the answer is no. There are many ways in which the many meanings of design. And from the engineering aspect, design is actually designing for functionality. That means you design to solve a problem, you design something to do a certain action or perform some function that's useful. So in mechanical engineering, the design would need our knowledge of mainly physics, maybe a little bit of chemistry, depending on the branch, and mathematics. Okay, so when we teach about design, we are going into the principles of physics and mathematics and teaching you how to apply those to real situations. Then the second part of mechanical engineering is manufacturing. How would you bring something to life so that we can use them? So here are the rough basket of modules. Of course, they have specific names, but these are the modules that you will study in that 15 modules of ME major modules. So mathematics is part of it. It's not really, theoretical. We won't ask you to prove a certain theorem, but, we need to know how to apply the mathematics. And then when you have thermodynamics, solid fluid mechanics, and so on, those are more the Newtonian physics part of the physics that you've studied in school, or whatever science subject you've studied in school. And then the other parts, such as manufacturing, computer-aided design, that is linked to the manufacturing space. And of course, the CAD/CAM is part of bringing your design so that it can be manufactured. And then control and automation is part of making sure that whatever you design, if it's an autonomous system or it's a machine, it will work. Then finally, we have also put internship under the core modules. Internship is compulsory for all students except poly students who have already had internship experiences. And internship is great because future employers love that our students have some kind of industry experience. Okay, so they turn up for work a bit more professionally. So those are the core modules. Now, what about the 10 unrestricted electives that you can use? So one option is to do specializations, okay? So specializations are certain topics in mechanical engineering we have identified as being more useful in the future workplace. And so in the specializations, we bring together certain related electives, and you can also opt to do a longer project, a final year project in this particular specialization area so that you have a deeper knowledge of these areas. So the specializations we have are these: aeronautical engineering, energy and sustainability, robotics, offshore oil and gas. So with these all just require 5 modules or the equivalent of 5 modules. If you do a project, it's equivalent to 2 modules. So it's either a combination of electives, all 5 being electives, or electives and a project. Okay, so these are some of the options that you can have. I will talk about the application to these specializations a little later, but this is certainly something that you can do with 5 of your unrestricted electives. Now, what about the other things that you can do? So if you're interested in ME, here, we have various projects which actually are quite large scale. So our famous one is the FSAE race car, which goes yearly to the US. And, so far we've done quite well in the rankings for a country that actually doesn't have much of an automotive industry. So we also have, we have something on land, we also have something on the sea and under the sea. So Bumblebee is a project that our students have. So they have an autonomous surface vehicle on the sea, which goes around and does various tasks. They also design and build an autonomous underwater vehicle that again is able to function on its own, doing various tasks. So these 2 projects are part of a second major in innovation and design, and I'll talk about the second major later. So, but if you're interested, you don't want to do a second major, but you're just interested to meet, other students who like to tinker with their hands and do something fun, we have something like RoboMaster, which is a collection of robots that fight each other. There are also different teams that come up with flying vehicles. And later on, our SME president, Yong Heng, is actually a member of our UAV team. So it's a plane that flies, and he can share with you some more of his experience about how he can, indulge in his passion for flying things and also earn some credits at the same time. So these are the things that are, really related to mechanical engineering that you can consider a specialization on one of these projects. Now, but The curriculum in CDE is very, very broad. And it's also very flexible. So you would have seen this from my colleague earlier on. We have a common curriculum consisting of both university requirements and also the college requirements of giving you various broad skills. And then we have that 15 modules of engineering majors modules. And then you have this free space with 10 equivalent to 10 electives. So, you can choose what you want to fill in that space. You can fill that space in with electives from everywhere, outside of mechanical engineering, some inside, some outside, in whatever proportion you want to. So that's the freest form of it. But some people want a bit more focus, a bit more direction. So we have suggested some options, and this is only just some options. For example, you can do 2 specializations within ME. You can do a second major. So if you're interested in FSAE and you're interested in Bumblebee, you can do a second major in innovation and design. You can also do a specialization and a minor, and you can do 2 minors, and you can do 1 minor, and then the rest free. So you can see here that there are over 35 second majors for you to choose from, and double the number of that in terms of minor and specializations. While we're here, let me just explain a little bit what a specialization is and how is it different from a minor. So a specialization is something that is focused on a certain topic, and it is within your major. So if your major is mechanical engineering, your specialization such as aeronautical engineering falls under the umbrella of mechanical engineering. So it's called a specialization. A minor is something that's outside of your major. So it can be in another engineering discipline, or something in arts, or like econs or sociology or something like that. Okay, so a second major can be a related discipline such as innovation and design, or it can be outside of that. So of course the major requires more modules because you're kind of like majoring in it, but not as much as your primary major, while specialization and minors are a bit more free and easy. Okay, so here, this second slide here, you can see that depending on what your interests are and where your passion lies, where your aspirations are, what do you want to be in your career, we have suggested we've just shown some examples of how you can actually go about doing that. So if you're interested in aerospace, to work in the aerospace sector, you can obviously take the aeronautical specialization and maybe add on a robotics one, because automation is definitely important in that industry. Then we've suggested here a systems engineering second major. Systems engineering is about, how do you apply business concepts to complex systems, such as engineering systems. So it's very relevant. You can be an automation engineer, systems design engineer. Then another option is a minor plus a specialization. Here, an energy specialization coupled with a minor in information security can allow you to work in, let's say, energy security, which is actually very important. How do people not hack into your energy network? So it requires you to know what kind of energy systems we have, and also a little bit about, the cybersecurity part. So that's certainly possible. Then, if you're interested to work for, let's say, Boston Consulting, Accenture, those kinds of consulting companies, you can do, 2 minors in those areas, one in management, one in econs, or a second major in management. And then the final example, I think you may not be aware of, is we have one of the minors is called interactive media development, which talks about marketing through, online and social media and web and so on. So many companies, startup companies in particular, come up with technical products, and they do need somebody who understands both the technical part and the marketing part in order to bring it to market successfully. So you could be a digital marketing engineer with that combination of modules. Now, after speaking for the last 25 minutes, you might be a bit overwhelmed, especially with the last 2 slides. So just to reassure you, you do not have to do a specialization second module minor, okay? If you just want to choose anything for the 10 modules, language, music, business, whatever, forensic science, you can too, okay? Or if you're just interested in becoming a good, well-rounded engineer and you want to choose, mostly other mechanical engineering electives, you can do that as well. You don't have to specialize or focus on anything else. So you can choose as narrow, as wide as you like, and there's still time. You don't have to decide on your major now or your specialization or minor now. You can decide later. However, there are some quotas for things like aeronautical engineering and robotics. So we kind of split the quota in half at the point of admission and half, after year 2. So if you take up and, you're slightly kiasu, you go and opt for one of these, you don't want to do it, there's no penalty. Nobody's going to fault you for that. And you can always switch to something else or not at all. So I want to finally get to this last part, which is important for a lot of parents and also obviously for you who are thinking about doing mechanical engineering, is what are the careers out there? So I want to just show you that the scene in Singapore is actually very vibrant for mechanical engineers. So these are newspaper articles taken in this month, February, where you can see that after being hit with the slowdown over COVID, aerospace companies are really on the lookout. So if you go and Google for jobs by Rolls-Royce, there are a lot of jobs out there. So what I did yesterday was to take a look online at the kind of jobs that are offered by some of the well-known names. Some of them are engineering companies, some of them are not, and to show you what is out there for you. So Airbus has something called an airline marketing analyst, where they said we need a mechanical engineer or somebody with aeronautical background, because you are supposed to go and sell their planes to customers, okay, like SIA and so on. So you can do that. And DSO, interestingly enough, has something called a thermal R&D engineer. So that's where you can see the thermal systems come in. Dyson also has jobs for mechanical engineers. And then the next two, JP Morgan and McKinsey, they are obviously well-known names in management consulting, and they have jobs for JP Morgan is a bank, of course. They have jobs for engineers as well. P&G, even though you might think of it as a pharmaceutical company or the manufacturer of detergent, they are looking for mechanical engineers in their process development, and it's a degree. It's a position that requires a higher degree in mechanical engineering as well. So Rolls-Royce and ST Aerospace. So this is just the pick of what I did an online search yesterday. So you can see that the hiring situation is very vibrant, and it's also you can find jobs in all sorts of industries, and they're all different kinds of jobs. So there's definitely something to suit you as a mechanical engineering major. So here, I just wanted to bring up, I know it's very important to many people, what's your starting pay? So this is the last 5 years of data for some of the major engineering disciplines. You can see mechanical engineering being the red line, it's smack in the middle. And it's not surprising it's smack in the middle, because mechanical engineers are so versatile. They take on such a broad range of jobs, so that when you average things out, it's not surprising to find that mechanical engineering is in the middle. Of course, with the digitalization of a lot of systems and logistics industry going into overheating, it's not surprising to see that industrial and systems engineering students command the highest pay because they can do coding, they can do algorithms and so on. But not everybody is cut out to do programming and mathematical modeling. So mechanical engineering is actually quite decent. If you look at chemical engineering, actually it's on a downward trajectory. It was stagnant for a while. It's the line in green and it's on a downward trajectory, which is not very good. Mechanical engineers are making more and more pay, steady, but steady and slow is good. At least you don't get shocks like a drop in pay and so on. So that's just for you to see. All this data is available on the MOE website online. So now, after having said all that, maybe you're interested. I mean, if you're here, I hope that you're interested. Then you're asking, so is it really for me? I have a few questions for you. And if your answer is yes to all of that, then maybe consider ME. First of all is you must not hate maths, okay? You don't have to love it. You don't have to be super good at it, but you do need some competency. You need to be proficient at it. As I said, it's not the proving a theorem, but it's an application. You do need to be comfortable enough not to run away screaming if you see math, okay? So any engineering will need math. Second is, if you really like to find out how things work, then engineering is definitely should be at the top of your mind to consider as a subject of study. Then what about mechanical engineering? So I've shown you so many examples that in mechanical engineering, we do mostly with physical systems and objects, things that we can touch, things that we can see, things we can visualize. So if you're a person who prefers Newtonian physics and can't get over the electrical atomic part and electromagnetic part of physics, then I think ME is a safe bet for you. Then, because ME is so broad and so versatile and found in so many industries, the basic ME skills that we give to you are very versatile and can be applied to a broad range of jobs. And so you will get access to a broad range of careers. And so if you say yes to all this, know also that as long as people are physical beings and we need, clothing, transportation, all those things, ME skills will always be in demand. So just very quickly to round off my sharing, why would you want to choose ME at NUS? Why not NTU and SUTD and so on? So let me give you some things to ponder. So with the new curriculum, you can see that it is completely flexible. It is really up to you how you want to craft your degree. You can be totally ME, do specializations, or just do all 10 modules being in ME. Or if you just want basic ME knowledge, but apply it to somewhere else, then you also have that flexibility. And the red tape is very, very minimal compared to before. So the curriculum is there to allow you flexibility to follow your interests. Now, NUS is a very established university. So, if you want to do something with your unrestricted modules like language, like music, like forensic science, you're not going to find it elsewhere in another university. Only NUS offers you that freedom and breadth of modules. And also with the breadth and diversity of modules you get diversity in student life. You meet all sorts of people from different backgrounds, different interests. If you live in a hall or you take part in some of the CCAs that are, campus-wide. And of course, we have some of the top facilities. A lot of things are new. And so you do benefit from the ecosystem that is NUS. And also, the strength of NUS means that global opportunities are unmatched by any other university in Singapore. So I know a lot of students are interested in global opportunities. So first, we have NUS Overseas College, which is a long-running, nearly 20-year endeavor, and we are very popular with startups in many locations around the world. But most of you may not go to NOC, but a lot of you would be interested in student exchange, and NUS has the largest number of student exchange partners worldwide. So one thing to note is that for engineering students, we are the only university in the world where our engineering programs have exchanges with Oxford and Cambridge, and it's a one-year exchange with either university. And so, for example, because ME is such a bedrock of any engineering school around the world, you will always find that there are opportunities for exchange. So giving the example of Cambridge, chemical engineering students cannot go to Cambridge because there's no agreement, there's no chemical engineering department that we can agree with. It's part of chemistry. So, ME students can go to Cambridge, but not chemical engineering students. So you will find that ME really has the largest number of options when it comes to overseas. So finally, I just want to end with this slide. We have a very dynamic faculty. These are some of our new professors who have come in only in the last 2 years. One thing you'll notice is that there are a lot of women. It used to be just me and another couple of ladies in the department, but we have gone on a really aggressive hiring drive, and you can see so many women in ME right now as professors. So to the girls who are interested in ME and think, is it for the guys? Am I going to be outnumbered by the guys? Of course, you'll be outnumbered by the guys. It happens in most engineering disciplines, but know that young, dynamic, and some of them really quite pretty professors are your role models, so you don't need to fear anything. We hope to be able to welcome you as freshmen into ME at CDE, in the near future. So thank you and goodbye, everybody.